Welcome to this note. Honestly, think of this as a global masterclass mixed with a professional mentorship session. Today, we're going to unlock the invisible engine that powers the entire modern digital economy. Whether you're looking to launch a massive tech career, build a startup from the ground up, or really just understand the nervous system of the digital world, you are in exactly the right place.
Okay, so let's just dive right in. Have you ever actually stopped to wonder how data packets, like the very pixels you're looking at right this second, zip around the world so flawlessly? And more importantly, have you ever considered how you can actually monetize understanding that exact process? See, most people are just passive consumers of the internet, but the moment you understand how it works under the hood, you instantly transition from a consumer into a builder.
Well, it all boils down to one massive concept: TCP/IP. This is the foundational protocol system. It is literally the language of the internet that allows every single device on the planet to communicate. It completely doesn't matter if it's a massive enterprise server in Tokyo or a smartphone in London. TCP/IP is the universal translator making the whole shebang happen. All right, here's our roadmap for today. We're going to break down the internet's hidden engine. Look at how TCP/IP actually works. Dive into addressing and subnetting. Track the actual journey of a data packet. Peek into AI and future networks. And finally, talk about monetizing your skills.
Okay, part one, the internet's hidden engine. Let's start with the sheer scale of the internet and why understanding this is so absolutely crucial to your future opportunities.
We are literally talking about billions of devices here. TCP/IP is the digital transportation system that allows all of them to exchange information reliably. And here is the truly mind-blowing part. It does all of this without a central controller. It's this massive, decentralized, chaotic, yet beautifully efficient system where enterprise cloud architectures and, your smart fridge all share the exact same digital roads. Moving on to part two, how TCP/IP actually works. Because to really grasp this global network, we have to look at the elegant layers that make it all possible.
You might have heard of that super academic 7-layer OSI model, right? Well, scratch that for a second. Out in the real world, TCP/IP uses a highly practical 4-step meal plan: application, transport, internet, and network interface. A great little memory trick for this: just remember the mnemonic, all teachers inspire networking. ATIN. It's just 4 simple layers that take your data, prepare it, route it, and physically blast it across the world. Now, if we zoom in on that transport layer, you've basically got a massive choice to make: TCP or UDP. TCP is like your meticulous accountant. It absolutely guarantees reliable error-check delivery, making sure every single piece of data arrives perfectly. UDP, on the other hand, is the total speed demon. It happily sacrifices perfect reliability for raw, unadulterated speed, which is exactly why it's the protocol powering things like live video streaming and gaming, where you just can't afford to wait for a lost packet.
All right, section 3, addressing and subnetting. Because for any of these billions of devices to actually talk to each other, they need to know exactly how to find one another in this massive ocean of connections.
And that brings us to subnetting. Honestly, think of subnetting like taking a massive, totally chaotic city and carving it up into neat, organized zip codes. It's an absolutely ingenious architectural method used to slice huge networks into secure, manageable little pieces. Whether you're managing a local office building or architecting a global cloud environment, subnetting gives you way better performance and dramatically tighter security.
So here is what that actually looks like in the trenches. Using CIDR notation, like a /24 for example, and subnet masks, engineers can map out highly specific address ranges. And look, mastering this exact skill of IP addressing and subnetting, it's a foundational, completely non-negotiable requirement for almost any high-paying tech career. It is literally the difference between just guessing and actual engineering.
Okay, part 4, the data packet journey. With our network all addressed and beautifully segmented, let's track how the data actually moves from point A to point B.
When you hit send, your data doesn't just fly through the wires as one giant block. No way! It gets chopped up into these tiny, manageable chunks we call packets. Each chunk then gets encapsulated with headers. It's literally just like writing a destination and return address on a piece of mail. Finally, it gets passed from router to router across the globe using a store and forward method until all the pieces reach their destination and magically reassemble. So how does this whole system survive massive cable cuts and outages? Well, it shares resources dynamically rather than locking down a dedicated path.
It runs on a best effort delivery service. But the real genius here? It's the end-to-end principle. The routers sitting in the middle of the internet are kept relatively dumb and incredibly fast. All the heavy lifting, the error checking, the actual intelligence, that's all pushed out to the edges, to your computer and the server. That is what keeps the core of the internet lightning fast and infinitely scalable.
Section 5. AI and Future Networks. Because mastering all these foundational rules isn't just about understanding today's internet. It's about future-proofing yourself for the rapidly evolving world of digital infrastructure.
AI is just absolutely transforming the networking space right now. We're shifting away from reactive IT support and moving straight into AI-powered predictive analytics that can actually spot network failures way before they ever happen. We're seeing the explosion of automated troubleshooting, incredibly smart cybersecurity systems, and literal self-healing networks. If you really understand the underlying TCP IP mechanics, you position yourself perfectly to build and manage these cutting-edge AI tools.
Which brings us to part 6, monetizing your skills. Because now that you know the mechanics and the future, how do you actually turn this into a digital income stream? Let's talk real business value. Your networking skills hold some serious, immediate freelance value. We're talking basic router setups going for $50 to $150, all the way up to premium security audits that can easily pull in $200 to $1,000. And these are just beginner to intermediate rates. Every single small business, remote worker, and startup relies entirely on their network. When it inevitably breaks, they are more than happy to pay for solutions. And it goes way beyond just trading your time for hourly rates. You can build highly scalable businesses here. Think managed IT service subscriptions for that sweet recurring revenue. You can share your knowledge through YouTube education, or even create and sell digital products, like network troubleshooting checklists or subnetting cheat sheets. The modern knowledge economy heavily rewards anyone who can explain complex technical systems simply. So, if you want to make this a reality, here is a super actionable 90-day success roadmap. Month 1, go all in and master those TCP IP fundamentals. Month 2, start getting your hands dirty, build home labs, spin up virtual projects. Month 3, go after industry certs like the Network Plus or CCNA and start pitching your very first freelance clients. It takes consistency, for sure, but the path is proven. As we wrap up this note today, I really want you to burn this core ethos into your brain. The internet rewards builders. It is the central infrastructure of modern life, and the people who truly understand this digital nervous system are the ones who are going to capture the most value.
You now understand the fundamental language of the internet. You're not just a consumer anymore. So get out there, spin up a lab, experiment, break things, fix them, and go claim your spot in the digital economy. What are you going to build with it today? Thank you so much for joining me in this note, and I'll see you in the next one.